So let's do an explicit example of using the Euclidean algorithm to solve a linear Diophantine equation. So we'll start with the equation 500x plus 423y equals 1. Now, one thing we might wonder about is, does this even have a solution? Because maybe 500 and 423 aren't relatively prime to each other. Not too hard to see that they are relatively prime in this case, but in general, it's a little tricky. Well, what would we need to do? Take the GCD. Well, that's going to come out already from the Euclidean algorithm. So there's really no additional work there. You might as well just go ahead and try it. So Euclidean algorithm has many uses, and we're seeing a new one. But if you think of it as just trying to find the GCD, you take 500 and you divide 423 into it. It goes in one time. Remainder 77. Okay. And the new thing is we're going to solve that for the remainder, because we're going to build a chain of equations on the right here that's going to allow us to express 1 as a combination of 500 and 423 eventually. Okay, so now 423, continuing on the left-hand side, is 5 times 77, goes in 5 times, the remainder of 38. And let's just finish this. 77 is 2 times 38 plus remainder of 1. Aha! So this is good news. The remainder was 1. They are relatively prime. There is a hope of solving this equation. Okay, so now I'm going to solve all those for the remainder. Pretty easy. Just isolate the 38, isolate the 1. And then I just use a chain. I start out with the 1. It's kind of a funky thing. We're starting with something simple and kind of expressing in a complicated way. It's the usual, it's opposite of kind of simplification you often see. But that's because we want to see if we can express 1 in this very particular way as a combination of 500 and 423. So this says 1 is a combination of 77 and 38, just like this. But wait a minute, 38 was built out of building blocks that are closer to what I want, namely 423 and 77. So I'm going to substitute that in. So 1 is 77 minus 2 times 38, and I've substituted this in for the 38. I distribute that out, I simplify, and I see that 1 is now 11 times 77 minus 2 times 423. Okay, so that's cool. Okay, yeah, just by checking my arithmetic. Okay, so now the 423 is actually already good, but the 77 is not what I want to be. But of course, 77, why was that in the calculation in the first place? It was remainder of the first division involving 500 and 423. So that tells me how to express 77 in terms of 500 and 423. I just substitute that in, I distribute, and then I simplify. Voila! I've expressed 1 as a combination of 500 and 423. The coefficients turned out to be 11 and minus 13. Those weren't obvious at the start. They're not present necessarily right here. They're not even exactly present here. They come out of combining these equations step by step by step and expressing things as higher and higher remainders and terms in the Euclidean algorithm, going back up the Euclidean algorithm. But it's a very straightforward procedure to find them. So 11 and minus 13 turns out to be a solution to 500x plus 423y equals 1. You can check it if you don't believe it, just substitute them in. But it really, really works.